Welcome to Unit 2, Lesson 6, Different Forms. Our objective for today is let's use the different forms of polynomials to learn about them. Okay, first example, which three go together? So, what we could say is that A is the only one that's in factored form. Factored form helps us draw the graph. B is the only one that has a leading coefficient that's not 1. So B has a different leading coefficient. The coefficient is the number in front of the highest degree. C is the only one that does not have a constant that's 24, negative 24. And D is the only one with an x cubed term, and it has 4 terms. So they all have something different going on. But let's show you how to do A very quickly. So with A, if I take x and I multiply them, I get x squared. If I take negative 4 times negative 6, that gives me negative 24. I don't know what the middle term is, but I'm not going to worry about that. This one helps with the shape of the graph, and the last term helps me where it crosses the y-axis. So pick 3, put them together, and tell me why the other one doesn't belong. That was today's idea. Okay, we got dimensions of a cake box here. Identify the degree and leading term of the polynomial is what the question is asking us to do. If we take the negative 2x and multiply it to negative 2x and multiply it to x, that will give us the degree and the leading term. Negative 2x times negative 2x times x. Negative 2 times negative 2 times 1 gives us positive 4. X times x times x gives us x cubed. Okay, now let's look at number 2 here. Without graphing, what can you say about the horizontal and vertical intercepts? The beautiful thing about the factored form, this polynomial is in factored form. If you set each factor equal to 0, you can find the x-intercepts. So x equals 0 is 1. 8.5 equals 2x. If you add 2x to both sides, move to negative, divide by 2, x gives you 4.25. If I add 2x to both sides, 14 equals 2x. I divide by 2, and my other one is x equals 7. I have 3 factors in my problem, 1, 2, and 3. I get 3 roots, x's or zeros. Okay, so that's for the horizontal intercepts. Okay, so now let's look at the vertical intercepts. Okay, because this is not an x plus or minus anything, this is going to multiply. I can already see that usually you would multiply the 14 and 8.5. But because this term is only x, that's going to get multiplied to whatever constant I get. I'm going to prove it, but I know already that the y is going to equal 0. So we're going to multiply, we're going to distribute, and then distribute and distribute. So 14 times 8.5 is 119. 14 times negative 2x is negative 28x. Negative 2 times 8.5 is negative 17x. Negative 2x times negative 2x is negative 4x squared. And don't forget about the x. Combine like terms, which are these two in the middle. You get 119 minus 45x minus 4x squared. We're going to multiply this by the x. We're going to distribute this x to all terms. We're going to get 119x minus 45x squared minus 4x cubed. We're going to rewrite this in proper order. Negative 4x cubed minus 45x squared plus 119x. There is no constant term in this, and that tells me that this graph goes through 0. Okay, so now let's practice multiplying polynomials. To multiply polynomials, you use a distribution method. So the first term times the first term in the next, and it has to multiply. I have 2 terms in the first and 2 terms in the second binomial. 2 times 2 is 4, so I should get 4 terms out. So make sure you draw your arrows so that you know how many terms you should get out. So when I multiply, I get 4 terms out. 2 of them will be alike. I get x squared plus 6x plus 8. And that's just like my other polynomial. Again, practicing. I get 2 terms here and 2 terms here. 2 times 2 is 4. I just draw my distribution arrow so I know to multiply. And that gives me x squared plus 1x minus 30. Now, mathematicians are lazy. They don't like writing ones. But if you leave a 1 in your answer, it should not mark it wrong. Okay, let's look at something a little bit more, the next level up. So we got 3 terms times 2 terms. 2 times 3 is 6. So now watch my distribution. I got to do the 2x to all terms. So I should have 3 arrows up top. Then I have to do the -1 to all terms. That gives me 3 arrows down the bottom. So 2x times x squared is 2x cubed. When you multiply variables, the exponents change, they add. 2x times 10x is 20x squared. 2x times 7 is 14x. Then I do my -1 distribution, and I get -1x cubed. No, x squared, I'm sorry. -10x and -7. And so now what I'm going to do is group my like terms. My -1x squared plus 20x squared. My -10x and my plus 14x. When you get more terms, you'll have more pairs that are alike. So 2x cubed plus 20 minus 1 is plus 19x squared. 14 minus 10 is plus 4x minus 7. And for the last one, I get my x squared to 4x cubed. I get my x squared to -8. I get my 3 to 4x cubed. I get my 3 to -8. Okay. X squared times 4x cubed is 4x to the 5th. When you multiply variables, the exponents add. Minus 8x squared. Distributing the 3, I get plus 12x cubed, and then minus 24. I have to rewrite it in proper order because this is out of order. So is 4x to the 5th plus 12x cubed minus 8x squared minus 24. And these are my terms. Okay, let's talk about this. You know by sitting in class how to put these polynomials into y equals. So we know how to put this one in the y1, put this one in the y2. The odd thing about the second one, g, is it has this 1/2. What this 1/2 means is that the curve is going to be half as high as the original one. So whenever you multiply a polynomial by a constant, it changes the high and low. So now let's look at this. Using graphing technology to graph both functions in the same windows, the first number is this is the standard setup when you turn your calculator on. Now to get into the Windows menu, you have to hit the window button. So at the top of the calculator, there's a button that says window. You're going to hit that button, and what's going to pop up? Y min, Y max, or it might be max and min. Max might be on top, min might come second. Then Y scale, then X max, X min, and X scale. All right, this is going to be set to 10, negative 10. The scale is going to be 1. That means it goes by 1. X max is going to be positive 10. X min is going to be negative 10. X scale is going to be 1. So look at the variable you're changing. You're changing Y. So we're going to change this one to positive 100 and this one to negative 100. And remember, the negative is this one. It's down next to the decimal. So it's the button next to the decimal button, next to the 0. So make sure you're hitting the negative before you put the 100 in. And then you're going to hit graph because you want to look at the graph. If you would have graphed based it on this one, you would have only seen part of the graph. But now that we opened up the windows, we made the highs higher and the lows lower, you will see more of the graph. And we need time to practice that. You actually had to push the buttons on the calculator. I cannot stress this to you. Please push the buttons on the calculator so you know what's going on with the windows. Okay, so now what degree do these polynomials have? You have 1, 2, 3 x's. So we know that these are x cubed. So now rewrite each expression in standard form to check. So we're going to distribute and distribute x squared plus 3x. We're going to distribute and distribute minus 2x minus 6, giving us x squared plus x minus 6. And now I have to do x minus 7. And so again, distributing. I get x cubed plus x squared minus 6x. And now I'll distribute my 7 3 times. My negative 7. Remember, the sign in front of the term goes with the term. Negative 7x squared minus 7x plus 42. My x squared. I get x cubed minus 6x squared minus 13x plus 42. And for g, all I got to do is multiply everything by 1/3. So if I multiply this whole thing by 1/3, I get g. So that will change up everything. That would make the highs higher and the lows lower. Okay, so h of x. Put this one into y3. So the first one went into y1. This one goes into y2. And then see what you get. Try that one.